Hi guys, welcome to our notes for 1-9. It's titled, What's in a Root? Today we're going to look at simplifying radical expressions. So our recent work with rational exponents leads us into a review of radical expressions. Today we will look at simplifying, adding, subtracting, multiplying, and dividing radical expressions. Let's get started. First, how do we simplify radicals? And everyone may do it differently depending on how you've learned it in the past. I'm sure that you've probably seen it for the last 2 or 3 years over and over, maybe different ways, maybe the same way. If you're one of those people that can memorize perfect squares, great. You could probably look at this first one and say that this is going to be the same thing as the square root of 16 times 3, because you know 16 is a perfect square. And we break that into the square root of 16 times the square root of 3, and then you get 4 radical 3. And I'm fine with that if you want to do it that way. Others of us that maybe struggle a little bit with it would maybe want to break it down into its prime factorization. Right? We already know that it breaks into 16 times 3. 3 is a prime number, 16 is not. We know 16 can break into 2 times 2 times 2 times 2. It's 2 to the 4th power. And then times 3. And remember that when you are taking the square root, it's like you have the root number out here is 2. Right? We don't write it out there, but just thinking about, we're looking for pairs. I look inside of here, 2 times 2 is the same thing as 2 squared. That's a perfect square. And then we'll take this pair as a perfect square. And when you do that, you can pull out a 2 from that pair. You can pull out a 2 from that pair. You have 2 times 2. And then what's left over inside our square root is 3. We get 2 times the square root of 3, which is also 4 times the square root of 3. For those of you that struggle a little bit more with remembering your perfect squares, that might be a little bit easier for you to remember. That's also going to benefit you in problems like the next ones. We have the cube root of 48. Now we're looking for perfect cubes. Well, if we think about that prime factorization, it's the same thing as it was in the previous problem, 2 times 2 times 2 times 2 times 3. Now we're looking for a perfect cube. Well, when I take that factor of 2 and I multiply it times itself 3 times, that's like 2 to the 3rd, or a perfect cube, right? So that 8, the cube root of 8, and I'm sorry, I forgot my cube root there. The cube root of 8, I'm going to take it and I'm going to pull out that 2, and what's left over is just this 2 and 3. Well, 2 times 3 is 6, so we have 2 times the cube root of 6, and we've simplified the cube root of 48. The last one, we're looking at the 4th root of 48. So one more time, let's take it here and set it up. We have the 4th root of that prime factorization, 2 times 2 times 2 times 3. And we do have a factor that multiplies times itself 4 times. So 2 times 2 times 2 times 2 is 16, right? And we could take that there, and we take the 4th root of 16, that is going to be a 2. We'll pull out that 2, and what's left over is the 4th root of 3. And that one has been simplified as well. How do we add and subtract radicals? Well, we look for like radicals, just like when adding, subtracting expressions with variables, right? We know something like a plus b, we can't simplify anymore, but I could do a plus a, and I know that is 2a. So we treat radicals like variables when we are trying to combine like terms. The first one, we have 2 radical 3's plus 4 radical 3's minus 7 radical 3's. When I take the 2 radical 3's and add 4 radical 3's, I actually have 6 radical 3's. And then if I take away 7 radical 3's from that, we get a negative radical 3. The next one we look at, we have the square root of 8 plus the square root of 32, or radical 8 plus radical 32. They are not like terms. The reason that one above worked is because it was radical 3, and radical 3. But we might be able to simplify. We know the square root of 8 is the same thing as the square root of 4 times the square root of 2, which gives us 2 radical 2. And the square root of 32 is the square root of what, 16 times the square root of 2, which is going to be 4 radical 2. So we have 2 radical 2 plus 4 radical 2. Now when we look at it, they are like terms. So when we take those 2 radical 2's plus the 4 radical 2's, we get 6 radical 2's. The next one, we have the square root of 20 minus the square root of 300 plus the square root of 45 plus the square root of 27. So we need to break those down. Square root of 20, right? Our factors are 4 and 5, so we should get 2 times the square root of 5 minus 300. Well, we're thinking about 3 and 100. The square root of 100 is 10, so we have 10 radical 3 plus 45, we have 9 and 5. Square root of 9 is 3, so we have 3 times the square root of 5. And then 27 is 9 times 3, which is going to give us 3 times the square root of 3. Now, as we look at it, we've got 2 radical 5, and we have plus 3 radical 5. And then we also have a negative 10 radical 3 and a positive 3 radical 3. Let's just combine the like terms, and we'll end up with 5 radical 5, and then we have minus 7 radical 3. And that would be our answer, because they wouldn't be able to take it down anymore. Let's move on. Now we have one with cube roots. So we have the cube root of 16 plus 4 times the cube root of 54 minus the cube root of 2. So again, when we break down the cube root of 16, remember that is 2 times 2 times 2 times 2 underneath the cube root. So when we take that out, we're going to have 2 times the cube root of 2 plus, and then we have the cube root of 54. Well, the cube root of 54 should break down into, let's see, we got 54. We'll do it over on the side. We've got 54 breaks into 27 and 3. 27 is 3 to the third, so that looks like it's going to be 3 times 3 times 3. I'm sorry, this was a 2 times 2. So when you think about cube root, taking the cube root of this, we've got 3 3's in there times a 2, so we've got 3 times the cube root of 2. Now don't forget about this 4 though. We have plus 4 times 3 times the cube root of 2. And then the last part of it here does not break down, it's just the cube root of 2. 4 times 3 is going to give us 12 cube roots of 2. So we have 2 times the cube root of 2 plus 12 times the cube root of 2 minus 1 cube root of 2. We combine our like terms, and it looks like we get 13 times the cube root of 2. And that would be our answer. Next one. Please make sure you're paying close attention on this one, because this is not asking you to FOIL. This is talking about subtraction. You are going to take it and we are going to distribute this through. Every year there's people who miss problems like this because they see the 2 sets of parentheses and want to multiply. This is the same thing as saying 3 plus 5 radical 3 minus 5 minus a negative radical 12. So minus a negative radical 12 is like plus radical 12. We know that radical 12 breaks into 2 radical 3. So when we take this and bring this all down here, we can combine our like terms. We've got 3 and negative 5 are going to give us negative 2. And 5 radical 3 and 2 radical 3 would give us 7 radical 3. So we end with negative 2 plus 7 radical 3. Now multiplying radicals. You'll see the rule up here. If we have the nth root of A and the nth root of B, okay, so it means it's the same root, either square root and square root, cube root and cube root, whatever it is, it's the same root, we can rewrite it as the cube root of the product of what we have inside. So what we're looking at here, the square root of 6 times the square root of 3, we can rewrite this as the square root of 6 times 3. Now you can take it and break that into, turn it into the square root of 18 and then break it down. Or you can think about it as 6 is 2 times 3 times another 3. We're going to pull out that 3 and we have 3 times the square root of 2. 14 times 28. Okay, or I'm sorry, the square root of 14 times the square root of 28. But when we put that together, that is 14 times 28. Now some people will take this and break this down to the prime factorizations, make 14 2 times 7 and 28 2 times 2 times 7, but let's just think about it for a second. We're looking for pairs. So if I do 14, and I know 28 is just 14 times 2, I don't have to break it all the way down because here is my perfect square, 14 squared, which we know because when we memorized our perfect squares, we know that's 196. But we don't actually have to turn it into 196 because we can pull it out now and make it 14 radical 2. Next one, the cube root of 25 times the cube root of negative 10. All right, again, this is one to make sure you pay extra close attention on because this is the first one. This is the first one where we have a negative inside one of the roots. When we take this and put this together, I'm looking at 25 times my negative 10, right? This is the cube root of 25 times negative 10. All right, when we break that apart, we know that 25 is just 5 times 5, and negative 10 is a negative 1 times 2 times a 5. So in this case, we end up with 3 5s. We have a negative 1 and then a 2. We need to think about what are all going to be perfect cubes. Well, our 3 5s, we'll pull a 5 out. Negative 1 is a perfect cube. Think about it. Negative 1 times negative 1 times negative 1 is negative 1. So that is a perfect cube. So we're going to pull out a negative 1 as well. And then what's left over is the cube root of 2. So we multiply it together. We have negative 5 times the cube root of 2. And that is our answer for that one. So with negatives, right, we're just going to keep it and just keep that one negative factor. We'll pull it out because it's always going to be a perfect cube. Anytime it's odd, anytime it's an odd root, that negative will come out. When it's even, we know that we can't have it in there, and that's when we have to start dealing with i's. We're not doing those today, though. Now the last one at the bottom, we have the cube root of 18 times the square root of 2. First thing to go back to is thinking about our rule up here. Do we have the same roots? Okay, we do not. We could take it here. If you wanted to try to simplify either of them, you could, but in this case here, there isn't a perfect cube that goes into 18, and the square root of 2 is simplified. This one does not simplify anymore. This is the answer. Okay, so we don't have the same root. Let's move on. Now we got a little bit more multiplying here. This one, we're multiplying two binomials, and this is where we will FOIL it. So we're looking at taking this and we're going to do 1 times 2 is going to be 2. 1 times radical 6 is radical 6. Negative 2 radical 3 times 2 is negative 4 radical 3. And then negative 2 radical 3 times a radical 6 is going to be negative 2 radical 3 times 6 is 18. And that one simplifies a little bit more. Remember, 18 is 9 times 2, so that would become 3 radical 2. So when we do that, we have minus 2 times 3 times radical 2, or negative 6 radical 2. We'll bring down the rest because there are no more like terms. So this ends up being our answer. As long as, if there isn't anything that can combine, that would be our simplified answer. If there was something else we could combine, we'd do it, but we can't. All right, so let's move on. Next one, 4 minus 2 radical 5, and that quantity is being squared. For those of you that need to do it this way, just take it and break it apart. Please do that. There's always mistakes that occur here where people just try to square the 4 and the 2 radical 5. You can't do that. So don't do that. Let's do our foiling here. We're going to do 4 times 4 is 16. 4 times 2 radical 5 is going to be negative 8 radical 5. And then we're going to get a second one of those. And then negative 2 radical 5 times negative 2 radical 5 would become 4 times radical 25, which is 5. Now that we've got that, we can start to combine our like terms. These two are going to go together. So 16 minus 16 radical 5 plus 20. Combine our 16 and 20 to get 36 minus 16 radical 5. And that is it right there. All right, moving on. How do we divide radicals? Again, just like with multiplying, we need to make sure that we've got the same root value. If we do, we can write it as 1 root with a fraction inside. For example, the square root of 40 divided by the square root of 2 is the same thing as the square root of 40 halves. And 40 divided by 2 is going to be 20. And now it's pretty easy. Just going to simplify the square root of 20, which we know 4 and 5, which would give us 2 radical 5. Same thing happens with our cube roots. We can take this and say this is going to be the cube root of 32 over 4, which is 8. The cube root of 8 is going to be 2. So this is just a really more confusing looking way to write the number 2. All right, let's do some more with these. Now we can also go the other way, where we see the square root of 4/49, but 4/49 doesn't reduce anymore. But since we know 4 is a perfect square and 49 is a perfect square, this is the same thing as taking the square root of the top and the square root of the bottom. Square root of 49 is going to be 7, and the square root of 4 is 2. And we get 2/7 as our answer. Same thing happens with our fourth roots. Here we could take this and say this is like the fourth root of 8 over the fourth root of 81. Now 8 we know breaks into 2 times 2 times 2. So there isn't even we need a fourth 2 to be able to break that down, so it won't break down anymore. Our fourth root of 81, well, we know 81 is 3 times 3 times 3, that's 27, times 3 is 81. So you could think about that here as that's going to become just 3 in the bottom, and on the top, we're going to keep that fourth root of 8, and that is our answer, the fourth root of 8 over 3. Next ones. Oh, is that it already? We're having such a good time. If you have questions about any of these, I know that this is an area where some of you struggle. You need to make sure you're reaching out and, getting some extra help, some extra practice, whatever you need, I'm here to help you. All right. Good job. Thanks for watching.